Three logical operators, a doubled ampersand for and, a doubled vertical bar for or, and an exclamation mark for not. Before we use them, one rule underpins everything. In C, a value used as a condition is false if it is 0 and true if it is anything else at all. Not just 1, anything non-zero. -5 is true. 0.1 is true. A pointer holding a real address is true. That is why the last two lines work. Writing if PTR is exactly equivalent to writing if PTR is not equal to null, because a null pointer compares equal to 0 and any other pointer does not. And if not count is exactly count equals 0, because the exclamation mark yields 1 when its operand is 0 and 0 otherwise. Both spellings are idiomatic and you will meet both. The shorter forms read very naturally once your eye is trained. If PTR says if we have a pointer, but there is no shame in the explicit versions. And on a mixed experience team they are often kinder. Here is the property that makes the logical operators far more than a convenience. Logical and evaluates its right-hand operand only if the left-hand one is true. If the left is false, the answer is already false, so the right side is never touched at all. Logical OR is the mirror image. If the left operand is true, the answer is already true and the right side is skipped. This is called short-circuit evaluation, and the crucial word is guarantee. It is written into the standard. It is not an optimization your compiler might apply on a good day. It is behavior you are entitled to depend on, and C programmers depend on it constantly. All three lines on screen are examples of the same pattern, a cheap safety check on the left, and something on the right that would be catastrophic if the check failed. Test the pointer, then dereference it. Test the index, then subscript the array. Test the divisor, then divide. In each case, the dangerous half simply does not run when the guard says no. The flip side of that guarantee is that the order of your operands is now part of the correctness of the program, not a matter of style. Both lines here are the previous slide's examples with the two halves swapped, and both are broken. The first dereferences P to read its value member before it has checked whether P is null. So when P is null it crashes, and the null check sitting right there in the same condition is useless, because it happens second. The second reads array subscript I before verifying that I is within bounds, which reads memory it does not own. That may crash, or it may quietly return rubbish, which is worse. So put the guard first. Always. And note what the box at the bottom adds, because it strengthens the guarantee. There is a sequence point at logical and at logical OR, at the conditional operator and at the comma operator. Everything on the left is completely finished, including any side effects, before anything on the right begins. That is what makes it safe rather than merely usually safe.